Welcome to the deep dive. We're here to plunge into complex info and pull out the key insights for you. Today, it's a fascinating journey into the cutting edge of AI. We're talking multimodal generation.
Indeed. And specifically, we're unpacking a really groundbreaking new generative model called OmniGen2. We've gone through quite a stack of research papers, study guides, our notes, basically everything centered around this system.
Think of OmniGen2 as like an open source Swiss Army knife for AI creativity. It pulls together a whole range of tasks, turning text into images.
Yeah.
It also really sophisticated image editing and even this thing called in-context generation.
Which is pretty cool. It means it can take an object from one picture you give it and reproduce it accurately in a totally new scene.
Exactly. So this deep dive should give you a shortcut to understanding how AI is getting, well, smarter and more creative. And there are some genuinely surprising bits about how they actually built this thing.
Yeah, we'll get into how OmniGen2 moves past old limitations with what they call a decoupled architecture. We'll also look at how they had to build their own high-quality data, which is a huge task in itself, plus a new way to evaluate these models and even a kind of AI self-reflection.
It's not just what it does, but really how it does it, and why that matters.
Precisely.
Okay, so let's set the scene a bit. This whole area, unified image generation, it's exploded recently. You've got heavy hitters like Google's Gemini 2.0 Flash, OpenAI's GPT-4o.
Right, really powerful models, no question.
But the research we looked at suggests they often hit a kind of wall, especially when you need really consistent, precise image editing or keeping a subject looking exactly the same across different generated images.
And that's a critical gap, right, for applications where you really need fine-grained control. That consistency is everything. This is exactly where OmniGen2 comes in.
So what was the issue with the previous version, OmniGen?
Well, OmniGen, its predecessor, tried a simpler route. You use shared parameters, kind of like one brain trying to do both text and image stuff. But the researchers found a key problem.
Which was?
The parts optimized for understanding text just weren't cutting it for the detailed work of image modeling. It actually got worse. The image quality declined when they plugged in a stronger language model.
Huh. That's counterintuitive. You'd think a smarter language model would help.
You would. But it highlighted a fundamental design issue. So for OmniGen2, they knew they needed a major shift. The whole motivation was to get past these limits, build something that could handle all these diverse tasks without sacrificing quality or control anywhere.
They realized just understanding the meaning, the high-level stuff, wasn't enough for top-notch image generation and editing. Needed more visual detail.
Exactly. Semantic encoders are great, but they struggled with the fine-grained visual precision needed. They needed something more specialized.
Which brings us to the architecture of OmniGen2. This is where it gets really technical, but also kind of cool.
Yeah, the core innovation is this decoupled architecture. So instead of forcing one set of parameters to juggle everything, which, as we saw, caused problems.
They split it up.
Right. They use distinct, specialized pathways. One pathway is optimized for language tasks, understanding instructions, context, and another is specifically built for the diffusion process, the image generation part. It's like having specialists instead of a generalist.
Okay, break that down for us. Two main pathways you had.
Yep. First, you've got a multimodal large language model, an MLLM. Think of it as the brain understanding the request. It handles the text, processes images for context, and provides the overall direction. It's based on Qwen 2.5 VL3B, a pretty capable model.
Okay, so it gets the instructions, but it doesn't actually paint the picture.
Exactly. That's the crucial bit. The image pixels are handled by the second pathway, a dedicated diffusion transformer. And, importantly, the way the system breaks down images into features using something called a VAE, or image tokenizer, those features feed only into the diffusion model, not the MLLM.
Ah, so the language brain doesn't get bogged down with raw pixel data.
Precisely. It keeps the MLLM clean, preserves its strong understanding abilities without needing tons of retraining just for image specifics. It's a clever way to avoid the complexity you see in some other models to try to mash everything together.
And it avoids other pitfalls too, right? Like those fixed query tokens?
Yeah, some models use these fixed tokens to pass information, but that can be limiting, especially if you have long, complex instructions. OmniGen2 uses the MLLM's richer, more flexible understanding its hidden states to guide the image generation. It's just a more robust way to do it.
Okay, and then there's this other piece, OmniROP. Sounds fancy.
It is pretty clever. It's a new kind of position embedding. Think of it like adding super precise location tags to everything, both text and image parts.
Not just where something is, but how it relates to everything else.
Exactly. It breaks location down.
Mm-hmm.
Sequence order, whether it's text or which image it is, and even specific 2D coordinates within an image. This helps enormously with consistency, especially in editing.
How so?
Because image parts that aren't supposed to change keep their identical spatial tags, their identical GPS coordinates, if you will. It helps the model understand, keep this bit the same, change that bit. It lets the model clearly distinguish between different elements, vital for precision.
Makes sense. So great architecture, but you need fuel for the engine, right? Data.
Absolutely. And this was a major hurdle. For open source models, getting good data, especially for tricky stuff like image editing or that in-context generation we mentioned, is really hard. Existing data sets often have, quality issues or just aren't available.
So OmniGen2's creators had to roll up their sleeves.
They did. They developed their own comprehensive data construction pipelines. And interestingly, they leaned heavily on video.
Video, how does that help with image generation?
Well, think about it. Video naturally shows subjects, people, objects moving, changing angles under different lighting, all within the same sequence. It's rich with dynamic information.
I see. So for the in-context data, they grabbed frames from videos.
Yeah, they extracted keyframes, used other AI models like Ground and DNO to identify and track subjects across those frames, even used AI to generate new backgrounds for those subjects to make the data more diverse.
Wow.
And then they had powerful visual language models write the instructions like, put this person seen in these frames onto that new background.
That's quite a process. What about the editing data?
Similar ingenuity there. They tackled common problems like blurry images or vague instructions in existing datasets. They started with high-quality images, used generative AI to randomly fill parts in, like digitally painting over a section.
Okay.
And then had other really advanced MLLMs look at the original and the altered image and write precise instructions. Change the color of the car from red to blue.
Yeah.
Or remove the hat from the person.
So generating the instructions from the examples.
Exactly. And again, they pulled editing pairs from videos too, capturing subtle changes like someone waving or an object moving slightly. They used sophisticated checks to ensure consistency.
Okay, this is all very clever data building, but then you mentioned reflection data. That sounds different.
It is. This is really pushing the envelope. It's inspired by self-reflection in language models. They created sequences where the model first generates an image based on a prompt.
Right.
Then a different AI model, they used one called Dubao 1.5 Pro, acts like a critic. It looks at the generated image and the prompt, identifies flaws, maybe says, the prompt asked for 3 apples, but you only drew 2, and suggests how to fix it.
And OmniGen2 learns from this critique.
Yes. It's fine-tuned on this whole interaction, the initial attempt, the critique, the suggested fix. It learns to sort of, evaluate its own work and improve iteratively.
That's fascinating. And AI learning to critique itself raises some big questions down the line.
It certainly does. And it ties into evaluation too. How do you measure how well a model does that in-context generation, keeping things consistent?
The existing benchmarks weren't good enough.
Apparently not. Things like DreamBench, they often lack complexity, maybe only one input image or no human subjects, or simple scenes. And just measuring pixel similarity isn't enough when you have multiple subjects or need nuanced evaluation.
So they built their own benchmark too, OmniContext.
That's right, OmniContext. Sure. It's designed to be much tougher, more real-world. It's a large data set, carefully collected, high-quality images, personal photos, AI stuff. It covers different context types, characters, objects, scenes, and has specific tasks within those.
How did they build that? More AI helping AI?
A hybrid approach.
Yeah.
MLMs help with initial sorting, but then human experts did careful curation. And they even used GPT-4o to help generate and refine the test prompts. It's quite comprehensive.
And how is it scored? Not just a simple pass-fail, I assume.
No, they use GPT 4.1 and other powerful AI to provide scores from 0 to 10, but also detailed reasons for the score. It measures 2 main things: prompt following, did it do what you asked, and subject consistency, did it keep the subject looking right.
And an overall score from those.
Yep, a geometric mean. The goal is much more explainable, robust evaluation than before, really understanding why a model succeeds or fails.
Okay, so innovative architecture, custom-built data, a new benchmark. Quite the setup. What about the results? Does it actually perform?
The proof is in the pudding, as they say. And yeah, OmniGen2 seems to strike a remarkable balance. Strong performance across the board, which is pretty impressive given its size. Remember, 3 billion parameters for the MLLM, 4 billion for the diffusion part. Relatively modest these days.
So it's efficient and effective.
Seems
Right.
so. In visual understanding, because it uses that capable but frozen MLLM, it gets solid scores on standard benchmarks like MMBench and MMU. It understands images in context well while staying lightweight.
Okay, good baseline understanding.
Yeah.
What about generating images from text, T2I?
Here it really shines, especially considering its efficiency. On Geneval, which tests understanding complex prompts, it scores 0.86.
How does that stack up?
Very well.
Yeah.
It actually beats other powerful unified models like Uniworld v1, and it's nipping at the heels of the state-of-the-art Bagel.
But didn't you say Bagel is much bigger?
Way bigger. That's the incredible part. OmniGen2 hits this performance with only 4 billion trainable parameters and trained on just 15 million image pairs. Bagel uses 14 billion parameters and trained on, get this, 1.6 billion pairs.
Wow. That's a massive difference in training data and size.
Huge. It really highlights the efficiency of OmniGen2's design. And on another benchmark, DBG Bench, testing long prompts, it also does great, outperforming Uniworld v1 and rivaling specialized models like SD3 Medium.
So strong text-to-image. What about editing? That was a key weakness it aimed to fix.
And it shows real proficiency there, making those precise, local changes without messing up the rest of the image. On Emu Edit, it got the top score for actually applying the edit correctly.
And for keeping the other parts unchanged.
Second best scores there, showing good preservation. On another benchmark, Jedit Bench, strong semantic consistency. The edits make sense. And crucially, on Embedded Bench, the paper claims it sets a new state-of-the-art for open-source models.
Especially on certain types of edits.
Yeah, particularly on action edits, changing what someone is doing. That seems to be where learning from video data really gave it an edge.
Okay, impressive. And the in-context generation. Putting a specific subject in a new scene.
It sets a really strong baseline on their new OmniContext benchmark, overall score of 7.18, which translates to significantly better performance than competitors in following the prompt and keeping the subject consistent.
So if you give it your cat.
It's much more likely to generate your cat in that new scene, yeah. Among open source models, it's leading the pack here, according to their tests.
And finally, that reflection capability. Did that pan out?
It's definitely an interesting exploration. When they fine-tune the model on that reflection data set, it could effectively look at its first attempt, spot shortcomings like wrong color, wrong number of objects, and then correct them in a second try.
So it actually improved its own output based on the critique.
Yeah, and it could even decide, okay, this looks good now, and stop the process. It's not perfect, but it's a fascinating proof of concept. Could this be a step towards self-improving AI generation? The big question.
Definitely one to watch. And the open sourcing aspect is important too, right?
Absolutely huge. They're releasing the models, the code, the data sets, even the pipelines they use to build the data. That's a massive contribution for other researchers. It helps tackle that data scarcity problem and makes this advanced tech more accessible.
Okay, so it's clearly a big step forward. But no model is perfect. What are the limitations? Where does it still struggle? The researchers were pretty open about this.
They were, which is good scientific practice. For you, understanding these limitations helps see where the tech might go next.
One thing was language disparity. English versus Chinese prompts.
Yeah, they noted English prompts generally worked better. It also had trouble generalizing sometimes, especially with instructions like modifying human body shapes.
Why is that?
Likely just a lack of enough real-world training data showing those kinds of specific, perhaps sensitive variations. Data is still key.
And input quality matters. Garbage in, garbage out.
Very much so. Low-quality or downsampled input images really hurt performance. You get blurry details, and it struggles to follow instructions accurately. Also, if you give it multiple input images, say, 2 different objects to combine,
Yes.
performance is much better if the prompt is really explicit, like take the apple from image 1 and the banana from image 2. Ambiguity trips it up. Clear instructions help.
Makes sense. And even in that core strength, in context generation, it's not flawless.
No. Occasionally, it still fails to reproduce the context object perfectly. They found cranking up the guidance helps, basically telling it stick closer to the prompt. But it's not a magic fix.
Suggesting maybe bigger models are needed for really complex cases.
That seems to be the implication. Scaling up might be necessary to nail those really tough, high-fidelity reproduction tasks consistently.
And the reflection model, that had quirks too.
It did. Sometimes it could over-reflect, kind of inventing problems that weren't there or making incorrect conclusions, or the opposite, failing to fix a clear error. or even following a bad critique.
What causes that?
Probably limitations in the MLLM they use for the critique part.
Yeah.
Its perceptual abilities aren't perfect, and simply needing more and better reflection training data. It's early days for that concept. But they hope this work spurs more research into AI reasoning and self-correction, maybe using bigger MLLMs or techniques like reinforcement learning.
So quite a journey we've taken there. We've really dug into OmniGen2, following the research from the core problems it addresses through that clever decoupled architecture and the innovative data work.
Right, things like OmniRow for positioning, using video data in smart ways.
All the way to its pretty impressive performance, especially given its efficiency, and acknowledging where it still needs work.
It's a great example of how fast this field is moving, multimodal AI especially. And the commitment to open sourcing is really commendable and shows how these unified models are getting smarter, integrating language and vision more deeply.
And we saw this intriguing glimpse of AI starting to, well, reflect on its own work, identifying errors, correcting them.
Yeah.
So the thought to leave you with as you process all this, what does it really mean for the future when these powerful generative AI models can not only create amazing things, but can also self-critique, refine, and actively improve their own output? That's definitely something to mull over.